in today's video, I'm going to explain you about KVL, Kirchhoff voltage law, in the subject of basic electrical engineering. In this video, I'll give you the theory related to KVL, the sign conventions, and an example model which will be helpful for you to solve the problems. Okay, but problems I'll be explaining in the next videos, because if I include problems it becomes lengthy, right? I'll try to include two examples for each KVL and KCL. Okay, let us get into the video. KVL states that the algebraic sum of potential differences in a closed circuit is 0. Closed circuit, you need to remember this. Okay, in a closed circuit, the potential differences, the sum of potential differences should be equal to 0. That is, it obeys the law of conservation of energy. It is also called as law of conservation of energy. I've seen this in the intermediate book of I say tuition to intermediate students, so I have seen in their book law of conservation of energy. So if you want to include, you can include this point also. KCL is called as law of conservation of charge. Okay, let us discuss about that later. And a closed circuit will have several elements, right? It can have batteries, it can have resistors, it has some elements like it can have a fuse, it can have a switch, whatever the basic circuit elements are there. It can have an inductor, capacitor, whatever it is. So at each and every element there will be a voltage drop or voltage rise. Okay, the potential difference will either drop or it will either rise. Two situations may happen. So when do you understand that the potential difference has dropped, or when do you understand that it has raised? I'll tell you. This is element 1 and element 2. It can be anything. It can be a resistor and it can be a battery, or it can be a resistor, battery, any combo it can be. If you are moving from positive charge to negative charge, then it is considered as drop. That is, you need to take negative symbol. If it is moving from negative to positive, then it is considered as rise, that you have to take a positive symbol. Okay, I know you guys are getting confused. Don't worry, I'll explain you with a diagram. So yeah, in this diagram, just give me a second, the papers are flying. Yeah, in this is not diagram, actually it is a closed circuit. Is it open at any point of time? No, right? There is no open switch or nothing is there for this. It is a closed circuit. Okay, in this, what are the elements you have? You need to identify that first. E1, this is battery, and this is also a battery. Element 1, element 2, element 3, 4, 5. We have total 5 elements here. So in this example, let us apply KVL. And KVL, you are applying in the direction of current. Current is going in this direction, right? KVL also has to be applied in this direction. So that is why I have put arrow mark like this. Okay. So let us see how to apply KVL here. So KVL is what? Algebraic sum of the potential differences, right? Algebraic sum of the potential differences in a closed loop should be equal to 0. So let us see how it works now. First, let us start with R1. From R1, let us start. So R1, at R1, what is the voltage? What is the potential difference? You don't know what is the potential difference at R1, but what do you know from Ohm's law? V is equal to IR, right? So it is not necessarily that every time you should know the potential difference. If you know the current and resistance also, you can find out. Okay, so we are going in this direction, right? So like this we are coming, like this we are coming. Okay, so from positive to negative it is going according to our direction, like it is going like this. So when we are coming like this, from positive to negative it has come. So ultimately the symbol will be negative. Okay, taking the symbol is only a big task, others will be easy for you. So now what is the current here? I, let us take small I R1, V is equal to IR, right? For this also same, positive to negative it is coming. So minus positive to negative, so it is negative symbol. Okay, why is it becoming blur always? Maybe because of my hand, it is focusing on my hand. IR2, next IR3. Why minus again? Because again from plus to minus it is going, right? And what is the current? I. See, in some cases you will have a junction here, you will have a separation here, you will have two different loops. In that case you need to calculate the equivalent current. That is different scenario that I'll explain you in the next video with some more complicated example, but for this will be enough. Next, what do you have? The next element is E2, right? So at E2 you're coming from positive to negative again when you're coming like this. Okay, so when you're coming like this, first positive then negative, right? So this will also be obviously negative sign, because when you're going from positive to negative, you need to take as negative only. When you're going from negative to positive, you have to take positive. Whatever is here in the last, that symbol you have to take. What is last? Minus. Minus E2 directly you can take, because this is a potential difference. At batteries, near batteries, you'll have the potential difference. Okay, next. From there you're coming like this and you're going like this, right? So when you're going in this direction, so like this, when you're going in this direction, negative first, positive next, right? So from negative to positive you're going. What do you mean by this? Plus symbol you have to take, because last what is coming? Plus. So E1 is equal to 0, because algebraic sum should be equal to 0, right? So what you can do here, what, like minus R1, R2, R3, let us send it to that side. So it becomes minus E2 plus E1 is equal to minus. When it comes to this side, it becomes positive, right? Now you can take I common. Okay, E1 E minus E2 plus E1 can be written as E1 minus E2 is equal to. Got it? So this is the law of conservation of energy. That is, the batteries will release some energy, and that the same amount of energy is consumed by the resistors which is present in the circuit. This is what it means. Okay, the batteries has released some energy. Whatever the energy is released by the batteries, the same energy will be consumed by the resistors which are present in the circuit. Okay, this is about the KVL. So in KVL, the very important thing is finding sign convention is important. See, sign convention is very important. Next, finding equivalent resistance, that is they are in series connection or they are in parallel connection, that is important. And finding the equivalent current, because if there is a loop, if there are more than one loops, then that is very important. That I'll explain in the next video. In the next video I'll take an example of KVL and I'll explain you. So this is all about this video. Thanks for watching the video till the end. If you're still having any doubts related to KVL or any other subjects, or if you are having any video recommendations, let me know in the comment section. Thanks for watching the video till the end. Let's meet up in the next coming video with another topic.